So using those properties, we are either going to condense them, which means push them together, or we're going to expand them, pull them apart. Starting with condensing. First thing is, in order to do these rules, the bases of the log have to be the same. So if I look at this first one, these are both just LOGs. What is the base of the LOG log? 10. What are these two logs doing? Adding. So when I push them into one log, what are the insides going to do? Multiply. So it's now 1 log. 5 times 2 is 10. So one single log. It's not like log 5 times log 2. The insides multiply. And then something that's going to be kind of like a step up from when you've done this in the past. If we can evaluate the log, we should evaluate the log. So log base 10 of 10. What is the answer of log 10? 1. If you can evaluate the log, you should. Because reminder, the base of this log is a 10. So 10 to what power equals 10? The answer to the log is the missing exponent that the base needs. So if you notice that log has an answer, you should write down what that answer is. Example 2, what's the base of the ln log? E. So these are both ln's. You are adding them, so when you push them together, what are the insides going to do? Multiply. So 1 log is kind of the goal on these. On example 3, we have a couple different things going on here. First thing you notice, what's the base of all of these logs? 3. So we can do these properties. We have adding. When I push adding together, what operation will they turn into on the inside? Multiplication. But this one has a front number. Where do front numbers come from? Exponents. They were exponents up top. So your first thing you should do is always put exponents back where they were. If it has a number, you should figure out what that number is. So log base 3 of 49 to the 1/2. What is 49 to the 1/2 equivalent to? 7. Because that exponent of 1/2, what does that actually mean? Square root. So when I rewrite this, I'm running out of space. I'm just going to write a 7 because 49 to the 1/2 is 7. So exponents should go back. And now you have 3 logs that are all adding together. What are all of those addings going to turn into when you push them into one log? Multiplication. So when you push them together, the base of the log stays the same. Number-wise, what's 4 times 7? And then you also have that y in there. Next one. What numbers can be put back as exponents? The 1/2 and the 2. They just go to the log they were touching. What is 6 squared? What is a 1/2 power the same as? Square root. I don't really care which way you write it. In terms of like practicality of using a log, we're probably going to be better with a square root than with an exponent, so I'm just going to rewrite it. These 2 logs have the same base, they're minusing, so now when you condense them into one log, instead of the insides multiplying, what will they do? Divide. Now whichever one is minusing, that's the one that goes on the bottom. So since the square root of x was the one minusing, that's what goes on the bottom. So whatever log is minusing, the minusing does the dividing, so it'll always go on the bottom of a fraction. Example 5. Couple different ways you can deal with this one. Orders of operations would tell us we should probably just do the insides first. So inside, parentheses, what is those 2 logs, what will they turn into once we push them together? Division. So what goes on the bottom, the x or the y? The y. What x, or that 1/3 is in front, so that 1/3 is an exponent. But do you see how it was like what's an exponent on? The x, the y, or both of them? Both of them. So there's a couple different ways you could write this. You could write it as xy to the 1/3. Or you could write it as x to the 1/3, y to the 1/3. Doesn't matter. Like, you can leave it as the fraction with the 1/3, or you can just put it on both of them individually. Main thing is, what radical is the same as a 1/3 power? Cubed root. So, two ways you can write this. Are you going to let me? I'll just put it over here. So you can either do one big radical or two little radicals. So when you guys check your answers with mine, no, there's always going to be some variation. I would say the first one is probably the main way you would see it written, but nothing wrong with that one. All right, last one on this section. Do we have any numbers in front that should go back as an exponent? No. Whenever you have a combination of both, the adding, what will the adding turn into when we push them together? Multiplication. What will the minusing turn into? Division. So whenever you have a combination of both, anything that is positive is the top of the fraction, because the top of the fraction is the multiplier. Anything that is negative, where would that then go? On the bottom, because the bottom of the fraction does the divider. So the fact that those two are adding means that those are up top multiplying. The fact that these two are minusing means that they're on the bottom dividing. So anytime you have a mixture of both positive and negative, so adding and subtracting, the adding ones all go up top, the minusing ones all go on the bottom. Technically, we're good here, but now looking at that fraction, is there anything we can do to maybe simplify it?
Back near the top.
Yeah. What's x squared minus 4? And if I break up that x squared minus 4, what will cancel? Yeah, the x plus 2's. So, final answer. So, condensing. Main thing is move exponents back to where they started. And then identify your main operators. It's either going to be adding or subtracting. Anything that adds is a multiplier. Anything that is subtracting is a divider. And just make sure if you have a mixture of both, anything minusing, just throw it on the bottom. Do we have any questions on condensing? All right, now we are going to be expanding. Expanding just means we are going to do the same process, but now we kind of have to identify it backwards. So the first one, what operation is going on inside of that log? Multiplication. If we split apart multiplication, what will it split with? A plus or a minus? A plus. So because it is 81 times x, it's going to be log base 9 of 81 plus log base 9 of x. So the 81 and the x are multiplying. So then when you split it, the 81 and the x, those are the ones that get their own logs. You should always try to simplify if you can. Number-wise, does log base 9 of 81 have a nice answer? Yeah, what is it? Close. 2. 9 to what power is 81? 2. And then that one can't be changed. All right, next one. That radical is really an exponent. What exponent is a square root? What did you say? Close. 1/2. What's underneath that radical? The 27, the x, or both of them? Both of them. So when you rewrite this, it is on both of them. So the 27 and the x are both underneath, so they both have that exponent. Where can that 1/2 be moved to?
The front.
To the front. So 1/2 log base 3 of 27x. Inside the log, what operation are the 27 and the x doing? They're multiplying, so when you pull it apart, what will they pull apart with? Addition. Now that 1/2, do you see how it's in front of it? So when I pull these apart, do you think they'll both get the 1/2 or just one of them? Both of them, because originally that square root was on both of them, so then they both get the 1/2. And then last step, if your logs are always numbers, you should see if it has a nice answer. So looking at log base 3 of 27, so 3 is our base. So does 3 to some nice power equal 27? 3 to what power? 3. What number's in front of it though? A half. So it'll be 3/2 plus 1/2 log base 3 of x. I don't know why I made this so small. I'm sorry. But we get a 3 from log base 3 of 27. That 1/2 is a multiplier in front, so it'll turn into 3/2 and then plus 1/2 log base 3 of x. Example 3. What's the base of the ln? E. So this is just log base e. What operation is going on inside that log? Division. So when you split apart division, what does it split to? Subtraction. When you split it, they are both going to have an ln. That 4 is an exponent, but is that 4 an exponent on the whole fraction or just part of it? Just part of it. So that's why I didn't move it to the front right away. On example 2, that exponent was for everything, so it can go to the very front. Here you can't move it until you already have them split. Now that exponent can go in the front. And then the ln of e. So the base of the ln is e. So e to what power is e? 1. So our final answer here will just be 4 minus ln x. Because if you ever take the log and the base and the number on the inside are the same thing, your answer will always just be 1. Because it's like log base 5 of 5. 5 to what power is 5? It's going to be 1. So if your base and the number on the inside are the exact same, it'll always just be a 1. Next one. Is that exponent to everything or just part of the stuff on the inside? Just part. So you can't move that 5 to the front first. Instead, what operation is going on inside that log? Multiplication. When you split multiplication, what will it split to? Addition. So log base b of 9 plus log base b of x to the 5th. Once it is split, now where can that 5 be moved to? The front. And it only goes in front of the log it came from, not like the entire front. Since we don't know our base, do you think we'll be able to get like log base b of 9 into anything nice? No, so we're just done right there. Any questions on that one? All right, on 5. What operations do we have going on?
Division.
We have division and what else?
Multiplication.
Multiplication. So that x to the 4th, you can see this x to the 4th written in 2 ways. On this one, it's in front of the fraction. If it were in the fraction, would it be on top or bottom? Where would multipliers go? To the top of the fraction or to the top? So just know this x to the 4th can be written either on the side like it is, or if it's on top, you would do this the exact same way. How many pieces do we have multiplying on top? 2 of them. We have x to the 4th and we have the square root. So those 2 pieces are going to be positive. So we have ln x to the 4th plus ln this square root. What exponent is the square root the same as? 1/2. So anything that was in the top of the fraction is positive. It's a multiplier. How many pieces do we have on the bottom? 1. Anything that's on the bottom is a divisor, so it's just minus ln of x plus 3 to the 5th. So anything on top gets a plus sign, anything on the bottom gets a minus sign. And then your last step, where do exponents get moved to? To the front. So the 4 goes to the front, the 1/2, the 5. With logarithms, there is no rule. There's nothing you can do with adding or subtracting within a logarithm. So the fact that it's x squared plus 3, you can't split adding and subtracting within a log. You can only split multiplying and dividing. So that is just stuck right there. If you have a plus or minus sign inside of your log, you can't do anything with it. That's your answer, yep.
Also, on the first page, you can have like a square root on the bottom.
Yeah, yes. You don't need to worry about rationalizing. All right, last one here. How many pieces do we have up top? 2. Anything that is in the top of the fraction, what will it split with? A plus sign. How many pieces do we have on the bottom? 2. Anything that's on the bottom, what does that get split with? Bottom is subtract. So anything on top is a multiplier, anything on the bottom is a divisor. So when I split this, I'm just going to kind of jump into the answer. I'm going to erase this. This is silly. All right, so up top, we have log of x. What's the other piece that's multiplying up top? The z. So then it'll be plus log z to the 3rd. What's on the bottom? What's our first piece on the bottom? 100. Since it's in the denominator, it's dividing, so it's minus log of 100. What's our other piece that's on the bottom? Y to the 4th. So then will that be a plus or a minus? A minus. So anything on top is a plus, anything on the bottom is a minus. And then just look to see if you have any like simplifying to do. Can we do anything with the log of x? No. What about the log of z to the 3rd?
Move that.
Good, move your exponent. What about log of 100?
10. 2.
2. Log base 10 is this is log base 10. So 10 to the 2nd power is 100. And then your last piece, anything we can move?
No.
The 4. So that is expanding. Do you guys have any questions on expanding? Okay, the last one. Do you guys want your calculator for? We have something called the change of base formula. So everyone get whatever calculator you use out. So all calculators somewhere have an LOG button and an LN button. What is the base of the LOG log? 10. So this is base 10. What is the base of the LN log? E. So the reason I mention this is if you had like LOG of, let's do 100. That's base 10. 10 to what power is 100? 2. So that is a nice answer that we know we could just like use our exponents, whatever. But what about like log of 98? In theory, shouldn't there be 10 to some power that would equal 98? It's probably just a really weird number. So this is programmed into your calculator. So if you find your log button, the log of 98, what decimal does that give you?
1.99.
Yeah, and that makes sense because like 98's a little bit smaller than 2, so our answer, or sorry, 98's a little bit smaller than 100, so our answer is a little bit smaller. So every exponent can be found. Calculators are programmed for sure to do these two. Now depending on your calculator, there's going to be different routes here. There's a change of base formula. So if I look at this first one, like 4 to some power would have to equal 17. What's 4 squared? 16. So it should be like 2 point something. Some calculators can change the base. Most calculators, I would say, cannot change the base. So there's something called the change of base formula. This change of base formula is essentially how we're going to solve equations next week. So the change of base formula is just a way so your calculator can solve any log regardless of what sort of calculator you have. And what that formula is log of A. So do you see how the inside number goes up top? The base of it goes on the bottom. So you create a new base that they are the same, and then as long as the bases are the same, this formula is going to work. Because your calculator has LOG and LN, the two most common bases that get used would just be finding the log of A divided by the log of B. And then the weird thing is, it doesn't matter what base you use, so you can also use ln A divided by ln B. So the change of base formula will just let you solve these on your calculator. So if you wanted to know what log base 4 of 17 is, formula-wise, you can just do either log 17 divided by log 4. So the way you punch it in, like do log 17, make sure you put a parenthesis after the 17, otherwise your calculator isn't going to know what you mean. Divided by the log of 4, and to 4 decimal points, what does log base 4 of 17 equal?
2.04.
It doesn't matter which log you use. So if you did ln 17 divided by the ln of 4, like just check it so you can confirm like you get the same answer. So because your calculator has log and ln, you can use either log. I would say the most common one to use is the ln. I don't know why, but that's the one that usually gets used. So either way will get you the answer. This next one, we're trying to figure out 14 to some power equals 87.5. It's going to be a weird number. When you type it into your calculator, which log goes on top, the 87.5 or the 14? 87.5. So you just do ln, I don't know why I put that in a parenthesis, divided by the ln of 14. So this is not the quotient rule or anything like that. Like this is its own standalone thing. So you should get to 4 decimal points. What number?
1.69.
6944. You would get the same thing if you did LOG. Doesn't matter which one you use. So change of base formula just allows you to solve any logarithm. You will know when to do this. When they're nice numbers, like you guys should be practicing like log base 4 of 16 and like using your exponents. But this is kind of just like your catch-all. Do you guys have any questions